Hi everybody, I'm doing a video today for ACT Review Packet 3, Algebra. Let's take a look at problem 19. Problem 19 says if the equation of the line is 4x minus 7y equals 14, what is the slope of the line? Well, in order to figure out slope, I really want to see slope-intercept form, y equals mx plus b. Right now the problem is in standard form where the variables are on the same side. So in order to be able to read the slope, I'm going to need to solve this equation for y equals. So I'll start with 4x minus 7y equals 14, and I'll think about solving for y first by subtracting 4x from both sides. And that'll give me minus 7y. Remember, you can't actually do any subtraction here because they're not like terms. One has an x, one doesn't. So we've got 14 minus 4x. And then divide everything by negative 7. I end up with y equals negative 2 plus 4/7 x. Or in slope-intercept form, y equals 4/7 x minus 2. I can see the slope is 4/7. Therefore, the answer to problem 19 is C. Okay, let's take a look at problem 20. Problem 20 says, the school trivia competitions, contestants are given two kinds of questions, easy questions and hard questions. Easy questions are worth 3 points and hard questions are worth 5 points. Nicole knows that she correctly answered 21 questions and that she had a total of 79 points. How many hard questions did she answer correctly? Well, we know she answered a total of 21 questions. That's made up of all the easy questions she answered plus all the hard questions she answered, and that total is 21. But we also know for every easy question, she got 3 points. So 3 points for every easy question, plus 5 points for every hard question, for a total of 79 points. Now, you can use either substitution, elimination. I guess you could use graphing here. I'm going to use elimination, and I'm going to multiply the top row by 3. So I'll have 3e, 3h, and 3 times 21 is 63. And then I'm going to subtract one equation from the other. So 3e minus 3e, the e's cancel. 3h minus 5h is negative 2h. And 63 minus 79 is negative 16. So when I divide both sides by negative 2, I get h equals 8. And we know from our first equation that the total number of questions was 21. Easy questions plus hard questions equals 21. So easy plus 8 equals 21. And when we subtract 8 from both sides, we get that the number of easy questions is 13. The number of easy questions is 13. But look, if we had taken the time to actually finish reading the question, we wouldn't have had to do this work. Oh no, it says here, the last line of the problem, how many hard questions did she answer? Look, I could have saved myself some time on the ACT. Then part of learning how to take the ACT is not just learning the content, but learning how to take the test effectively. So read the whole question, then start doing the work. Don't assume you know what the question is going to be like I did just then. Instead, read the question, then do the problem. Okay, let's take a look at the next one, number 21. What is the sum of the values of x for which 2x squared equals 2x plus 12? The sum of the values? Well, that means they want me to solve this equation, presumably get more than one answer, and add those answers together. So the first thing I notice is this is a quadratic. And no, I'm not going to take the square root of both sides. I'm going to subtract these things, move them onto the left side so that I can get everything on one side of the equation and therefore the equation equal to 0. So I'll have 2x squared minus 2x minus 12 equals 0. Now on the left-hand side, I can factor out a 2, leaving me x squared minus x minus 6. And this factors, as we learned in Algebra 1 and again in Algebra 2, x minus 3, x plus 2. And so when I set the factors equal to 0, x minus 3 could equal 0, so x equals 3. And x plus 2 could equal 0, so x equals negative 2. And a lot of students ask about this. Well, if I set this factor equal to 0 the way I set the other factors equal to 0, do I get a solution? Does 2 ever equal 0? No, it doesn't. This is not a solution. This is a stretching factor on this parabola. It stretches all the y values by a factor of 2. It doesn't produce any x-intercepts like these factors do. So we've got 2 solutions. And remember, our question is, what's the sum of these solutions? 3 plus negative 2 is going to be positive 1. The sum of the solutions is 1, and therefore my answer is D. Okay. Let's take a look at 22. Which of the following is an irrational solution to x squared minus 28 in absolute values minus 8 equals 0? All right, well, remember with absolute, whoa, did you hear that key word though in there? Irrational. Remember, irrational numbers are numbers like pi that go on forever, or e, or the square root of 2, or the square root of 3. Numbers that cannot be written as a ratio of integers. So let's see what we get here. Remember, with absolute value, we have to write both the positive component. Remember, with absolute value, we have to actually isolate the absolute value before we write the positive component and negative component. So the positive component, x squared minus 28 equals 8, and x squared minus 28 equals negative 8. So if I add 28 to both sides, I end up with x squared equals 36, where x equals plus and minus 6. That's not irrational. That's not what they're asking for. Let's try solving this one by adding 28 to both sides. I get x squared equals 20, and when I take the square root of both sides here, I get x equals, and don't forget, you took the square root of both sides, so you need to remember the plus and minus. So plus and minus root 20. Well, when I look at the answers, I don't see a plus and minus root 20, so I think I need to take this just a little bit further. I know that 20 is 2 times 2 times 5. Oh, look, a pair of 2's. So I can pull a 2 out and have square root of 5. Plus and minus root 5 are both of the irrationals, and our question says which of the following is an irrational solution, and choice G looks like this. Okay. That's it for the first 4 questions, the perform questions. Now let's flip the page and start working on the on your own questions. Okay. So, number 1. The graph below represents which of the following equations? Well, when I look at this graph, I notice that there's an ordered pair. Here, I'll show you the graph. I notice that there's this y-intercept at 0, negative 4. And I notice the slope is up 1 over 1, 2, 3. A rise of 1, a run of 3. I counted the rise over the run and got a positive slope of 1/3. So there's my slope, there's my y-intercept, and I want to write this in slope-intercept form. So I think y equals 1/3 x minus 4. Hey, there it is, choice D. that wasn't so bad. 2. In the xy coordinate plane, that just means on a graph, the lines M and N are perpendicular. Remember, perpendicular lines have opposite reciprocal slopes. So if the slope of one line was 2/3, the slope of the perpendicular line would be negative 3/2. So not only do we need the reciprocal, but we also need to change the sign. Okay, it says line M contains the points M contains the points 0, 0 and -3, 1. Well, if I use the slope formula here, I'm going to have 1 minus 0 over -3 minus 0, or 1 over -3. So we know the slope of the line perpendicular to this. When we flip this upside down and change the sign, the slope of the perpendicular should be 3 over 1. Now they give us some interesting information for line N, the perpendicular line. They say that line passes through -3, +1, and 0, z. Okay, well, let's see what that brings us. If I build the slope formula here, z minus 1 over 0 minus a -3. So I find that this is now going to be 3 equals z minus 1 over 3. I'm going to multiply both sides by 3. I'm going to get 9 equals z minus 1. I'll add 1 to both sides, and that will give me z equals 10. That's choice K. Okay, let's take a look at problem number 3. Problem number 3, which of these is an equation of the line that crosses through -3, 4 and 3, 6? Okay, so if I write the equation of this line, I need first a slope, and we said that slope would be rise over run, or y2 minus y1 over x2 minus x1. So I get 2 over 6, or 1/3. So I'm going to use a point and a slope. Doesn't matter which of these points. I'm choosing this point because it doesn't have any negative values, and I'm less prone to make sign mistakes if I use it. And this slope in y minus y sub 1 equals mx minus x sub 1. I prefer using point slope. I'll do the problem again using slope-intercept form, but I think this problem is easier if we use point slope form. Y minus 6 equals 1/3 x minus 3. On the right-hand side, I'm going to distribute. I'm going to have y minus 6 equals 1/3 x minus 1, and then I'll add 6 to both sides. Y equals 1/3 x plus 5. Okay, now if I was doing this with slope-intercept form, y equals mx plus b, I'm going to plug that ordered pair, because that's an xy ordered pair, along with my slope, into this equation. 6 equals 1/3 times 3 plus b. 6 equals 1 plus b. B equals 5. And now that I know that b equals 5 and m equals 1/3, I go back to y equals mx plus b, and I plug these values in. So y equals 1/3 x plus 5. Ta-da! There's number 3. Oh, but wait. Number 3 shows its answer not in slope-intercept form, but in standard form. So let's take a look and think about how we can go from slope-intercept form, y equals form, to standard form. Remember, standard form, ax plus by equals c. Notice the variables are on the same side. Well, so I need to get this variable onto the other side. I'm going to subtract 1/3 x from both sides. and I'm going to have negative 1/3 x plus y equals 5. Now I notice my solution isn't there. So I'm going to then get rid of this fraction by multiplying not just this, but this and this over here. I'm going to multiply everything by 3. I'm going to distribute 3 to everything. So I'm going to have negative x plus 3y equals 15. And that corresponds with, again, none of my solutions. But if I divide all of these by negative 1, I see x minus 3y equals negative 15, and that corresponds to choice B. Okie doke. All right, let's take a look at problem number 4. Problem 4 says, which of the following values of x satisfy the inequality 2 is less than or equal to 3 minus x over 4 less than or equal to 4? Well, I can split this into two separate inequalities, but I'd prefer to save time and just solve both ends simultaneously from the middle. So I'm going to subtract this 3 both from the left side and from the right side. And that's going to give me negative 1 less than or equal to negative x over 4 less than or equal to 1. Please don't lose this negative sign. Notice I brought it down here. Okay, so now I need to get x by itself, and I see here a negative 4. Well, to get rid of that negative 4, I need to multiply everywhere by negative 4. So here by negative 4, and here by negative 4, and I'm going to multiply everywhere by negative 4. So here I get 5, and here I get negative 4, and I'm sorry, this is positive 4. And now, what do we remember when we multiply or divide both sides of an inequality by a negative? Not only are we going to do negative times negative, and 4 divided by 4, but we're also going to be flipping the directions of the inequalities. Anytime you multiply or divide by a negative, you have to flip the direction of the inequality. And so my answer looks like this, which corresponds to choice J. Okay, problem number 5. The formula for converting Fahrenheit temperature reading to Celsius is Celsius equals 5/9 Fahrenheit minus 32. Which of the following is the Fahrenheit equivalent reading to 95 Celsius? Well, if I plug in 90, I have two choices. I can solve this equation for F and then plug in a 95, or I could just plug in a 95 for Celsius and solve the equation for F. I think that's what I'm going to do here. First, I'm going to multiply both sides by 9/5 so that these can cancel. I know many people like distributing. That's just going to make the problem longer. So I'm going to multiply both sides by the reciprocal of 5/9, which is 9/5. So I'm going to do some canceling here, and I'm going to get 19 times 9, which is 20 times 9, or 180, minus 9, which is 171, equals F minus 32. And if I add 32 to both sides, I get 203 degrees Fahrenheit, which is choice D. D for problem number 5. Okay? 6. Let's take a look at 6. Problem 6 says if x equals 1/3 t plus 2 and y equals 4 minus t, which of the following expresses y in terms of x? Well, I kind of want to solve one of these equations for t. So if I take this equation and I get t by itself, I'm going to see that t plus y equals 4, and if I subtract y, t equals 4 minus y. Now I know what t equals, so I'm going to take this and plug it in here. Okay, so what does that get me? That gets me x equals 1/3 4 minus y plus 2. Okay, if I distribute, oh wait a second, let's read the question. Expresses y in terms of x. Instead of x equals, they want y equals. So I need to solve this equation for y. Again, what tells me that? The words in the problem that say, which expresses y in terms of x. Y has to be in terms of some x stuff. So let's solve this equation for y. I'm going to start by subtracting 2 from both sides. Remember, when we're undoing or solving, since we're undoing PEMDAS. We're doing PEMDAS backwards or SADMIP. So I'll have x minus 2 equals 1/3 4 minus y. And then the next step, again, to get rid of this fraction, I'm not going to distribute it. Instead, I'm going to multiply both sides. Notice on the left, everything gets multiplied by that 3. And on the right, everything does too, but I'm canceling that 3 and that 1/3. I prefer this method to the distributing because distributing would give me a fraction, and multiplying both sides by the reciprocal gives me no fraction. It gives me 3x minus 6 equals 4 minus y. Well, we've almost solved for y. We still have 2 more steps. First, I'm going to subtract 4 from both sides and get 3x minus 10 equals negative y. And then I'm going to divide everything by negative 1. Notice how I divide not just some things, but all the things by negative 1. And get negative 3x plus 10 equals y. This seems to correspond with choice H for problem number 6. If I had been paying more attention at the beginning of the problem where it said expresses y in terms of x, instead of solving this equation, I would have solved this equation for t and then plugged that into the y equals equation. See, this one's already in y equals form. So if I go back and I solve this top equation, x equals 1/3 t plus 2, for t by subtracting 2, this may be familiar, and then multiplying both sides by the reciprocal, 3 over 1, 3x minus 6 equals t. And then I plug that into the other equation. 4 minus 3x minus 6 equals t. Don't forget to distribute this negative over here to this to get 4 minus 3x plus 6, or 10 minus 3x. That seemed to be a little faster. I could have saved some time if, again, I had carefully read the question. I wanted y equals as my answer. Okay, number 7. What are the xy coordinates of the point of intersection of the line 5x plus 2y equals 4 and the line x minus 2y equals 8? Well, finding a point of intersection is just solving this system of equations. And all I have to do for that, since these coefficients are opposites, is add these equations. 5x plus 1x is 6x. 2y minus 2y cancels as 0. 4 plus 8 is 12. So I end up with x equals 2. I still need to find y. The problem was very clear about finding an ordered pair, finding coordinates. So I'm going to plug this x value back in. 2 minus 2y equals 8. And subtract 2 from both sides. Negative 2y equals 6. And if we divide both sides by negative 2, I get that y should be equal to negative 3. So my ordered pair, 2, negative 3. Watch out for the common mistake where students, because they solve for this last and they're thinking about this number right now, they write the answer as negative 3, 2. This is not our answer. Our answer is 2, -3. Pay attention to those variables as you write this, and you'll see that the answer is C. Problem number 8. At a local theater, adult tickets cost $8 and student tickets cost $5. At a recent show, 500 tickets were sold for $3,475. How many adult tickets were sold? Well, this problem reminds me a lot of the test question from the first 4 we did on the perform section. I have a quantity equation. We've got adult tickets plus student tickets equals 500 tickets. But I can also build a value equation. Each of those adult tickets costs $8, and each of those student tickets costs $5. And we made a total of $3,475. Well, again, this is just a system of equations. I'm looking for the number of adult tickets, so I think I want to get rid of student. So I'm going to multiply the top line by 5. I'll have 5a plus 5s equals 2,500, and 8a plus 5s equals 3,475. Well, when I subtract, because these are the same, I'm going to have minus 3a, and over here when I subtract, I'm going to get 975. Negative, because this number is bigger than that. Then I'll divide both sides by -3, and I'll find out that a is 325. I have 325 adult tickets, and that corresponds to choice H for problem number 8. Problem number 9, what is the resulting coefficient of x when -x plus 6 is multiplied by 2x minus 3? Well, if I FOIL this problem out, I get -2x squared plus 12x plus 3x minus 18. Or -2x squared plus 15x minus 18. Now, notice the question was, what's the resulting coefficient of x? This is not x, this is x squared, so I don't care about that. This is not x, so I don't care about that. The coefficient of x is 15, and that corresponds to choice E for problem number 9. Okay, let's take a look at problem number 10. Problem 10 looks like this. If x squared plus 8x equals 48, and x is greater than 0, that means my solution is positive, what is the value of x minus 5? Well, again, please don't factor this and set each factor equal to 48. Instead, move the 48 over so that this quadratic equation can be set equal to 0. X squared plus 8x minus 48 equals 0. And then I'll factor here x plus 12, x minus 4 equals 0. And I'll set each factor equal to 0. Here I'll get x equals 4. Good, that's a positive value. But here I'll get x equals -12. Well, in the stem of the problem, they told me, no, x has to be a positive number. So not this number. I have to throw that away. And then they said, what's the value of x minus 5? So 4 minus 5 is -1, and that corresponds to choice G for problem 10. Problem 11. Which of the following solutions are the solutions to the quadratic equation x plus 1 squared equals 1 over 25? Well, here, in fact, I'm not going to FOIL both sides. Instead, I'm going to take the square root of both sides. So if I take the square root of both sides, on the left-hand side, I'm going to end up with x plus 1. And on the right-hand side, remember, because I took the square root of both sides of the equation, I now have a plus and minus. And if you're not sure what the square root of 1 over 25 is, why not split this up into two radicals? You'll get x plus 1 equals plus and minus. Square root of 1 is 1. Square root of 25 is 5. And then when you subtract 1 from both sides, you'll have x equals negative 1 plus or minus 1/5. That means x can be negative 1 plus 1/5, which is negative 4/5, or x can equal negative 1 minus 1/5, or negative 6/5. So what does that correspond to for our choices? It looks like C for us. That's problem number 11. Number 11 has the answer C. Okay, problem number 12. What's the value of 2x plus y given that 4x squared plus 6xy plus 2y squared and x plus y equals 4? Well, you know, I could stare at this and say I don't know what to do, but to me, this is looking like I need to factor that. And the first thing I'm going to do is take a 2 out of everything to make my life a little easier. And now I'm going to factor. In order to make 2x squared, I need a 2x and an x. And in order to make a y squared, I need a y and a y. I'm looking for a positive 3 here and a positive here, which I can get if I put plus and plus. Look, x plus y equals 4. So I can replace all of this with 4. 2 times 2x plus y times 4. 4 times 2 is 8 times 2x plus y. What is the value of, hey, this was equal to 32. So this is equal to 32. And this is equal to 32. And so if I divide both sides by 8, I get that 2x plus y equals 4. Here, let me go through that one again. Look, they told us that 4x squared plus 6xy plus 2y squared equals 32. And they told us that x plus y was equal to 4. And they asked us, what's 2x plus y going to be? So I said I'm going to factor the left side by factoring out a 2 and have 2x squared plus 3xy plus y squared. I'm not doing anything with the 32 on the right. I guess I could divide both sides by 2. In fact, I'll do that. And I'll have 2x squared plus 3xy plus y squared equals 16. Now I need to factor this trinomial. I went through that and said 2x and x, y and y, with pluses in between. Now, they told us that x plus y is 4, and here's an x plus y. So I'm going to replace this x plus y with 4. And that's going to give me 2x plus y times 4 equals 16. If I divide both sides by 4, I get that 2x plus y, the thing they asked me about originally, is equal to 4. And that corresponds to choice F for problem number 12. Okay, let's take a look at 13. What is the solution set for the equation? Okay, so I need to find the solution set. That means there's going to be more than one solution. And that doesn't surprise me because I've got an inequality. If you're comfortable graphing, and I like to think you are at this point, you can think of this absolute value shifted right 3 and then squished by a factor of 2. And the horizontal line y equals 13. And wondering when these two intersect. Well, they intersect at these two places. I'm expecting a positive and a negative solution. Let's go find them algebraically. We'll write our positive component as 2x minus 3 equals 13, and our negative component, 2x minus 3 equals negative 13. So if I add 3 to both sides, I get 2x equals 16, and if I add 3 to both sides here, I get 2x equals negative 10. I'll divide here by 2, I'll divide here by 2. I'll get x equals 8, and x equals negative 5. Okay, so which solution set contains both negative 5 and 8? That would be choice D. D contains both negative 5 and 8 in set notation. This is set notation we're looking at, and they ask for a solution set. Okay, problem number 14. If the number line below shows the range of possible values for b, which of the following shows the same possible values for b? Well, here's what I notice about this number line in number 14. The number line goes from negative 1 up to 5, and that the halfway point is 2. This distance is 3, this distance is 3. And so when I think about writing absolute value here, I'm saying the distance for any number from 2 has got to be less than or equal to 3. The distance from any number, a number over here or a number over here, that distance between 2 and that number, is got to be less than this total distance of 3. So I'm going to write x minus 2, or in this case they said b minus 2, is less than or equal to 3. This corresponds to choice J. 15. For what values of x is x squared minus 5x plus 6 less than 0? Well, I know I can factor this as x minus 3 and x minus 2, and that means I'm going to have x-intercepts at 3 and 2. If I think about this graphically, I'm looking at an upturned parabola, and these are the x-intercepts of that parabola. Now this question says to me, when is this parabola below, less than, the x-axis? Well, I see between the numbers 2 and 3. So I'm looking for an answer that says between the numbers 2 and 3. Well, that seems to be choice A. If I'm not comfortable graphing, though, don't worry, all isn't lost. Take this inequality and turn it into an equation. You still need to factor, and then you need to set each factor equal to 0. You'll get x equals 2 and x equals 3. Okay, so if we take those values and put them on a number line, and then test these intervals. So a number that's less than 2 is 0. I'm going to plug a 0 into this original inequality, going back to the original inequality here, and I'm plugging in a 0. I'm going to have 0 minus 0 plus 6. Is 6 less than 0? No. And if I plug in a number bigger than 3, like if I plug in a 4, 4 squared minus 5 times 4 plus 6, I'm going to have 16 minus 20 plus 6, 22 minus 20, or 2. Is 2 less than 0? No. So what about a number in here like 5 halves, 2 1/2? Let's plug 2 1/2 in and see what we get. 5 halves squared minus 5 times 5 halves plus 6. I'm wondering if this is less than 0. Well, when I square 5 halves, I have to square the top and the bottom, and that gives me 25 over 4 minus 25 over 2 plus 6 less than 0. And now I need to make a common denominator. Here I'll multiply by 2 over 2, and here I'll multiply by 4 over 4. I'll get 25 over 4 minus 50 over 4 plus 24 over 4. And that's going to be 49 over 4 minus 50 over 4, or negative 1 over 4. And that is less than 0. So my solution is between 2 and 3. I think the algebraic approach to this problem is much more time-consuming than the graphical approach, and I would encourage you to get comfortable graphing so that you could find choice A quickly and move on to the next problem, which is number 16. Problem number 16. What is the slope of the line given negative 12x minus 2y equals 14? Well, we talked earlier about slope being easy to read if I'm in slope-intercept form. So I'm going to get this in y equals form by adding 12x to both sides and getting negative 2y equals 12x plus 14, and then dividing everything by negative 2. I'm going to have y equals negative 6x minus 7, and I can see that the slope of this line would be negative 6, which corresponds to choice G. G for number 16. Number 17. What is the y-intercept of the line that passes through the points 1, negative 13, and negative 10, 31? Well, I don't know, so I think I need to write the equation of the line and then find the y-intercept of that equation. So in order to write the equation of the line, I need a point and a slope. I've got plenty of points, but I don't have a slope yet. So I need to use the slope formula, y2 minus y1 over x2 minus x1. And that gives me 44 over negative 11, or negative 4 is my slope. So if I plug in an ordered pair and the slope into y equals mx plus b, I should be able to find the y-intercept, or b. So I'm going to have negative 13 equals negative 4 times 1 plus b. And when I add 4 to both sides, I get negative 9 equals b. And that's choice A for number 17. Number 18. K minus 3 equals negative 5/3. Then 3 minus k equals what? Well, let's see. These look very similar. It seems like this is a positive, but now it's negative, and this is a negative, and now it's positive. And I could turn this into this if I just multiplied both sides by negative 1. So negative 1 over here makes this, and negative 1 on the right side, negative times negative, is positive 5/3. And that corresponds to choice J for number 18. 19. 3 over zy equals 2y over x. Then x is equal to what? So I want to solve this equation for x. And I find having x in the denominator makes me very uncomfortable. So I'm going to multiply both sides of the equation by x. This will do two things. One, it will get rid of the x in the denominator. Two, it will bring x up to the numerator. I like it. Then I'm going to multiply both sides by zy. So I'm going to be left with 3x equals 2y times zy. Well, these y's can be multiplied together to give me 2y squared z. But remember, the directions asked us to find what x was, not 3x. So I also need to divide by 3. I get x equals 2y squared z over 3, or 2/3 y squared z. This is choice, where to go? Choice A for number 19. Number 20. This problem is horrible. Horrible. I recommend you skip this problem if you're on the ACT, unless you feel like you've got plenty of time. It seems simple enough when I start the problem. Negative 3x plus 7 is less than or equal to 4, and x is an integer. Remember, integers are numbers like 2, 3, 1, 0, -1, -2, -3. Those numbers, okay? So let's keep that in mind as we solve this problem. All right, so the first thing I'm going to do is subtract 7 from both sides, and I'm going to get negative 3x is less than or equal to -3. And then I'm going to divide both sides by -3. Remember, when we divide both sides or multiply both sides of an inequality by a negative number, we change the direction of the inequality, and we get 1. Okay, so, I'm sorry, greater than or equal to 1. So we're asked for which of the following statements must be true. Must be true. Does x have to be greater than or equal to -1? No, x does not. Can't be 0. X can't be -1. So that's choice G gone. Can x be less than or equal to 1? No. No, x has to be greater than or equal to 1. This answer here, H, is here for the people who don't remember to flip the direction of the inequality. This is they're looking for you to make that common mistake answer, so not choice H. All right, so we've got F, J, and K. Well, K says x has to be less than or equal to 3. And we know x has to be greater than or equal to 1. So 5 and 7 and 8 can be numbers, but they wouldn't be numbers in this. So I'm down to 2 choices. I'm down to x is greater than 0, or x is less than or equal to 0. And many students choose this one because this one has the same inequality. But look, we know x has to be bigger than 1. Well, this is not going to be bigger than 1. These are going to be values less than 0. But many students say, but Mr. Kukla, how can that possibly be? You told us over here that x had to be greater than or equal to 1. How can this be the same as that? Well, remember they said that x is an integer. Okay, and notice here we don't have a line underneath, so 0 isn't included. What's the next integer after 0? 1. So this will be the same as this because we were told we're looking for an integer. I think this is a horrible question, and if I were taking the ACT, I would encourage you to skip this. This is problem number 20. Okay, 21. Brandy has a collection of comic books. She adds 15 to the number of comic books. Okay, so she's got number of books, and she adds 15 to that number. The collection, and then multiplies that sum by 3, the result will be 65 less than 4 times the number of comic books. Wow, that was an exciting translation. I'm going to distribute and get 3b plus 45 equals 4b minus 65. And then I'm going to subtract 3b from both sides and get 45 equals b minus 65. And then I'll add 65 to both sides. I get 110 equals b. And that corresponds to choice D D is the answer to number 21. 22. The toll for driving a segment of a certain freeway is $1.50. So you got to pay the $1.50 even if you stop driving. $1.50 plus 25 cents for each mile. Joy paid $25. Well, if we subtract $1.50 from both sides, I get 0.25 m equals 23.50. And when I divide both sides by 0.25, m will equal 94. Remember, you will have a calculator on the ACT to do computation like that, and so I get choice G. Base cost plus variable cost times the number of miles was the total cost. Problem 20, that was 22. Let's take a look at 23. 23 comes with a table. Which of the following equations best describes the linear relationship in the data told, where R represents the total number of pounds of rice sold and D represents the price in dollars of 1 pound of rice? So I'm looking for R equals some D stuff over here. I'm going to multiply pounds of rice times how much that rice costs per pound to get the, oh no, I'm not. Represents the price of 1 pound of rice. Okay, yeah, that's 1 pound of rice. Okay, well, let's see what we've got. When I look at this table, I've got the price per pound, and they told me that price of 1 pound of rice is called D, that's my input, and number of pounds sold, that's R. I notice that the numbers in this column are going up by 20 cents. And I notice the numbers in this column are going down by 2,500 pounds. What this tells me is every time I raise the price by 20 cents, I'm going to sell 2,500 fewer pounds of rice. Yikes. But what I also can do here is find a slope. And that's going to be a change in outputs divided by a change in inputs, or negative 12,500. Okay, so if I start thinking about which of these equations of lines has a slope of negative 12,500, I notice pretty quickly that I've only got two choices, C and E. One of them has a big y-intercept of 30,000 and the other 17,500. Well, I'm not sure which one mine is going to be, so I'm going to use the ordered pair 2, 5,000, and I'm going to write the equation of the line with this slope and this point, and I'm going to solve for my y-intercept. So 5,000 equals negative 12,500 times 2. Plus b. So that's negative 25,000 plus b equals 5,000. And when we add 25,000 to both sides to get b by itself, I see that b is 30,000. And since b is 30,000, that means our solution is E. E for number 23. Oh, how did I know to do this method with slope and to find these differences? Because in the problem they said there's a linear relationship. And so I knew I was going to be building the equation of a line in this problem. Okay, 24. This is a solution to the system of equations below. And that system is 3x plus 4y equals 31. And 3x minus 4y equals negative 1. If I add these two equations together, plus 4y and minus 4y cancel. 3x plus 3x will be 6x. 31 plus negative 1 is 30. And then I'll divide both sides by 6 to get x equals 5. Okay, Hey, and what is the solution for x in the system? That's what we got, so we're done. Our answer is G. G for number 24. How about 25? 25. What are the roots of the polynomial given by y equals 2 x plus 5, x minus 1, x minus 4? Well, right now we have factored form, and roots are something that I get when I set this equation equal to 0 and then set the factors equal to 0. I'll set each factor equal to 0. And solve each of these equations. I'll add 4 to both sides to get x equals 4. I'll add 1 to both sides to get x equals 1. I'll subtract 5 from both sides to get x equals negative 5. Does 0 equal 2? No, that's that stretching factor again. I've got 3 solutions, and none of them has a 2 in it. So which one is ours? Ours is choice A for number 25. Okay, 26. Which is the following is a factor of 6x squared minus 13x plus 6. All right, well, this is just a factoring problem. I would probably factor it 3x, 2x, 3, 2, minus, and minus. But some people aren't comfortable with guess and check at this point, and that's okay. We can go a longer way. I'm going to multiply these two numbers together and get 36. And I'm looking for the factors, two numbers that multiply to make positive 36, but that add up to be negative 13. Well, I know if they have to add up to be negative 13, they're going to be negative numbers. And I know they're both negative because the result of multiplying these two numbers together has to be a positive number. So I think I can think about negative 1 and negative 36. No. Negative 6 and negative 6. No. How about negative 9 and negative 4? Oh, they multiply together to be 36, and they add up to be negative 13. So I'm going to take these two numbers and replace this 13 with those two numbers. I'll have 6x squared minus 9x minus 4x plus 6. And I know there are more terms here now than when I started, but that's okay, because what I'm looking to do here is factor by grouping. So from the first pair, I can take out a 3x, leaving me 2x minus 3. And from the second pair, I can take out a negative 2, leaving me 2x minus 3. I have got two terms here. They both have a 2x minus 3 in common. So if I factor out that 2x minus 3, I'm left with a 3x and a minus 2. There's my solution, as I showed earlier, which is one of ours. This is G here. So there's the answer to number 26. How about 27? Which of the following is equivalent to 4x minus 1 and x plus 5? Well, this will be 4x squared minus x plus 20x minus 5. If I combine like terms, I'll have 4x squared plus 19x minus 5, and that corresponds to choice D for number 27. This was a simple foiling problem. 28. If a equals 4, then the value of 4a to the fourth plus 64b over 16 is what? Well, I don't know what b is, so there's going to be a b in my answer. I am, though, going to plug in this a equal to 4 here. So I'll have 4 times 4 to the fourth plus 64b over 16. Okay, so, I know you're thinking of pulling out your calculator now and doing a lot of heavy computation, But I'm thinking of rewriting this as 4 to the 5th plus 4 to the 3rd b over 4 squared. In fact, I think I want to split this up into 4 to the 5th over 4 squared plus 4 to the 3rd b over 4 squared. Then these two will cancel two of these. 4 to the 3rd is 64. And these two cancel two of these, plus 4b. You can certainly do this by pulling out your calculator and multiplying and then splitting this into two fractions and dividing. But I think working with exponents is pretty fast here. So for number 28, I've got h. What about number 29? X does not equal 8. And they tell us that in this problem because if we let x equals 8, 8 minus 8 is 0, and we don't want to be troubled by having a 0 in a denominator. So we're just going to look at x squared minus 11x plus 24 over 8 minus x. And I'm going to simplify this expression by factoring on top. I'm going to have x minus 8 and x minus 3 over 8 minus x. Ooh, look! These are almost the same, but they're opposites. Negative 8, positive x, negative x. So if I factor out a negative from each of these, that flips these signs. And then I can cancel this factor with this factor. So I've got negative x minus 3 left over. And if I distribute that negative, I end up with negative x plus 3, or using the commutative property of addition, 3 minus x. And that corresponds with choice A. A for number 29. All right, let's take a look at 30. 30 says 1 over 1 plus 1 over x. Well, down here I feel like I need to make a common denominator, so I'm going to multiply by x over x, and that's going to give me 1 over x plus 1 over x. And I remember my 7th grade teacher saying, don't be scared of this. This is just saying 1 is being divided by x plus 1 over x. And then she said, remember, when you have division involving fractions, you can always flip and multiply. So this is 1 times x over x plus 1, which is x over x plus 1. And that corresponds to choice G. G for number 30. Let's take a look at 31. Which of the following satisfies this equation? Well, wait a second. 31. 2x minus 6 equals negative 4. Let's think about this graphically. I shoved to the right 6, squished by a factor of 3. I'm sorry, a factor of 2. So there's my absolute value graph. And what's on the other side? The line y equals negative 4. When do they intersect? They don't. It says no solution. I don't have to do anything here. I know this is choice E. But if I didn't see that, I might see this. Hey, anytime I have a number in absolute value, whether that number is positive or negative, I always get a positive out. I can't get a negative out. No solution. Don't waste your time building the positive and negative components here. You'll only get the problem wrong. Pay attention to these details. 32. How many integer values of x satisfy the inequality? Absolute 2x plus 5 is greater than 11. Well, we could do this graphically, but I think I'm going to turn this into an equation and write the positive and negative components. And then solve each of them. I'll subtract 5. I'll get 2x equals 6, or x equals 3. I'll subtract 5. I'll get 2x equals negative 16, or x equals negative 8. So those are my two solutions. Well, those are my two critical points. If I put those critical points on a number line and test the intervals, let's see what I get. If I plug in a 0 into the original inequality, I get 5 is bigger than 11. No. If I plug in a 4, I get 8 plus 5 is 13. That is bigger than 11. And if I plug in a negative number, like negative 10, I'll have negative 20 plus 5 is negative 15, but the absolute value of negative 15 is 15, and that is bigger than 11. So this goes on forever. This goes on forever. How many integer solutions do I have? I think I have an infinite number of solutions. This goes forever. This goes forever. And so my answer here for number 32 is K. K for number 32. Okay, we're down to our last few problems. Problem number 33 says, for what values is x squared plus 9 less than 0? Again, I think about this graphically. I think about this x squared graph shifted up 9. And we're asking the question, when is this graph below the x-axis? Well, the graph is never below the x-axis. So my answer is E. If I were to, all right, so no, I can't even do this algebraically. Because look, I'd do this. I'd say x squared plus 9 equals 0, x squared equals negative 9, x equals plus and minus square root of negative 9, or plus and minus 3i. There are no real solutions. This parabola never intersects that line. Yeah, so this is just going to be E for us. There are no values of x for which the inequality is true. Okay, 34 says x isn't equal to 4, x isn't equal to negative 4. We don't have to worry about those. Those are just little domain restrictions for us, so we don't get into trouble dividing by 0. They give us this expression, x squared minus 16 minus 3x, x minus 4. And they ask us to simplify the expression. Well, when I look at all the answer choices, there's only one fraction, but here I have two separate fractions. I notice that this has an x minus 4 and an x plus 4 in its denominator, but this only has an x minus 4. I think I'm going to need to make a common denominator by multiplying top and bottom by x plus 4. Don't forget to distribute. So I'll have 4x minus 3x squared minus 12x over x minus 4, x plus 4. Or, if I tidy that up further, I'll have negative 3x squared minus 8x over x squared minus 16. And that corresponds to choice J. Our final problem, number 35. What is the value of x if x plus 1 over x minus 3 minus x plus 2 over x minus 4 equals 0? Well, I don't want to deal with these fractions, so I'm going to be multiplying everything by the least common denominator, x minus 3, x minus 4. X minus 3, x minus 4, and I'm even multiplying on the right-hand side by x minus 3, x minus 4. On the left, these cancel, leaving me x minus 4 times x plus 1, and then the x minus 4's cancel in the second term, leaving me x plus 2 times x minus 3, and on the right-hand side, 0 times all this stuff is just going to be 0. So I need to FOIL, and I need to FOIL. I'll have x squared minus 4x plus x minus 4, or x squared minus 3x minus 4. And then here, when I FOIL, I'm going to have x squared plus 2x minus 3x minus 6, or x squared minus x minus 6. But see how there's this negative in front that needs to be distributed not just to the x squared, but also to these other two here. So I'll end up with x squared minus 3x minus 4 minus x squared minus a minus is plus x, minus a minus is plus 6. The x squareds cancel out. Minus 3x plus x is minus 2x. Minus 4x plus 6 is plus 2. Okay, so what are the values of x if all of this, remember, equals 0? So let's solve this equation. Minus 2x equals minus 2, x equals 1. And that corresponds with choice D. Okay, there are 39 problems total from our ACT review packet on algebra. I hope this was useful. You might want to watch again if you need.